All right, here we are on the fourth example of the principle of mathematical induction. Before we actually start this, I'm going to refer back to our original strategies. Remember, we talked about when we were we're proving our k+1 step. This is the third step. We said that there were three different strategies you can use. So far, we've stuck with this first one of adding the left-hand side's version of one more to the right-hand side. In this next example, it's going to be the wisest choice to choose strategy 3. We're going to make our own representation with an equal sign, and then we're going to do one more with a k, and then show that the statement that we're trying to prove is still true. So, for example 4, we are trying to prove that 9 to the n power minus 1 is divisible by 8 for all positive integers, n being bigger than or equal to 1. So my first step is still the same. I have to show that this is true when n equals 1. So I will sub 1 in for n. 9 to the first is 9, minus the 1 is 8. You can factor an 8 out of that. It is 8 times 1, so that is divisible by 8. Check. Step 2, my assumption step. I'm going to assume that this is divisible by 8, and what I'm going to do is I'm going to actually make my own format for this. I'm going to say that 9 to the k power minus 1 is equal to 8 times some number. Right? K is still any positive integer. My m can be any whole number, because if you can factor 8 out of this and have a whole number left, then it is divisible by 8. Okay, so that's a little bit new for you. Next, step 3 is where I'm going to do my one more in my k, and then I have to show that that is still divisible by 8. So you see I've taken my original 9 to the n minus 1, and I've replaced that n with a k plus 1. This is one more. Now I just have to show that this here has to still be divisible by 8. And so what I'm going to do is, first, I can't really do much when there's the k plus 1 in the exponent. So I'm going to take this and factor a 9 out. If I factor 1 in the base out, then my exponent decreases by 1. So this is 9 times 9 to the k. Right, my minus 1 is still there. And now what I'm going to do is use a sneaky math trick. Remember back in step 2, I said 9 to the k minus 1 equals 8 times some number. So I can put this 1 on the other side, add 1 to both sides. That means anywhere in my equation, or in my expression, I see a 9 to the k power, I can replace that with 8 times m plus 1. So here where I have a 9 to the k power, I'm going to replace that with 8 times m plus 1. And then I'm going to simplify and see if what I have is still divisible by 8. So this 9 will distribute into my dark blue parentheses, right? Gives me 72m plus 9 minus 1. 9 minus 1 will simplify to be 8. And then here I can factor an 8 out of that entire expression. 72 divided by 8 is a 9, still with the m. 8 divided by 8 is a 1. So because I could factor an 8 out, and I'm left with all of these, remember m was a whole number, right? Times 9 is still a whole number, plus 1 is still a whole number. So I have factored an 8 out, and I have a whole number remaining. So this is divisible by 8, because 8 is a factor of that, which means that my original statement is true when n equals k plus 1. Because it is true when n equals k and when n equals k plus 1, I can, just like normal, end with my statement saying that by the principle of mathematical induction, 9 to the n power minus 1 is divisible by 8 for all positive integers.